Hello, everybody from all the world. Okay, so I'll be discussing the development of the test guidelines document on dustiness of nanomaterials, manufactured nanomaterials. I don't know. You need my camera on. I don't know if you put the camera on. Okay, I'll put that.
You can put it if you want.
Okay, here it is. All right, everybody. So it's with regard also to ATEX risk, atmosphere explosive risk, non-HARN and HARN measurements, and also exposure model. So this work, we had 2 sessions last few days on dustiness, and there was prepared by Ineris, NRCWE, BAWA, and BAWA. Next slide, please. So we had about 40 people on sessions. So dustiness is a key parameter, important parameter. It can be also defined as the propensity of materials to produce airborne dust during handling. It's very useful to get this dustiness level for risk assessment of exposure, for also assessment of accidental scenarios, for example, dispersion, fire, or explosions. So this is guidelines. Actually, this work is made of two things. One, technical guidelines on the ways of determinations of dustiness of manufactured nanomaterials, and 2 other guidelines, GD guidance documents regarding how the dustiness measurement are used for exposure modeling and for ATEX safety. So in the technical guidelines, we are concerned with HARN and non-HARN. HARN means high aspect ratio. HARN is like a fiber, a nanofiber, and non-HARNs. So these work will support requirements of regulatory needs, especially geared towards REACH, the regulation 2020 that came to this year, very early on dustiness, and the one also on to 2018. And also all the directive on ATEX explosive atmosphere regarding the safety of workers. 2 projects are enabling us to lay down the scientific basis of these initiatives. Go for Nano and NanoHarmony. We are studying nano objects that type like different type of dustiness of SiO2, TiO2, different type of HARNs, okay, and also reactive materials. Next, please. Yeah, so different apparatus, people may not know how dustiness is measured, but we have here in our group 7 different type of materials of test: a rotating drum, small rotating drum, vortex shaker, and so on. So the rotating drum, we have test that's led by TNO, a small rotating drum by NRCWE, vortex shaker by INRS, continuous drop method by TNO, and those are standardized already, European standardized, and we want to make sure that actually could be useful for on the worldwide scope. Fluidizer led by Bauer, and Venturi Dustiness testing device led by NIOSH, and continuous drop by BAM. So you have an example of setups on the right side. So next, please. Yeah, we have also 3 priority tests, because those we have tests with more than 5 labs. Those are concerning the rotating drum, small rotating drum, and vortex shaker. It will be the highest priority in your test. Next, please. So basically 18 international collaborators involved, Europeans and non-Europeans, basically. Next, please. So what are the consensus from these two sessions? The first consensus on ATEX, of course, we have on the TG that we are planning to do is to incorporate in the TG safety recommendation or safety caveat, including ATEX risk. regarding how when you have reactive materials, how you conduct the test, the Dustiness test. And this will be, we discussed also for the GD now, for the GD on ATEX, the determination of explosivity nature of the powder, and we proposed a flowchart that is useful for HARN, non-HARN, and reactive nanomaterials, and will be implemented in the GD. For the Dustiness testing program in terms of TG, and also you see you have TG and GDs at the same time. So that's why I mentioned what's going to be used for the TG and what's going to be used for the GD. For the Dustiness testing program TG, so what the consensus was that most proposed methods, I mean the 7 different methods, have potential to support regulatory information requirements for Dustiness testing. That we agree. This Dustiness testing program also can generate data and knowledge to establish also ranking systems, Dustiness ranking system for nanomaterials. This could be useful to assess occupational and ATEX risks, but also safety by design, basically designing nanomaterial to be safe, right? If you can design something that is less dusty, it's probably safer. We agree also that mandatory measurements should be harmonized and determined for all the method to the extent of possible extent. Next, please. In terms of the GD regarding the occupational exposure assessment, we agree that the content of the GD, okay, the GD should provide guidance on how to use Dustiness data to predict occupational exposure via the estimation of source. The source will depend on the energy, the handling energy of the systems, and the Dustiness kinetics. So we have also a database that gather database for 47 materials that includes exposure measurement and Dustiness level, Dustiness indices of these materials. So we call to expand this database to other materials that would have data on exposure measurement and Dustiness level. And if people have data, please contact Anna Sofia Fonseca. We have this mail here, and Carla Ribalta also. And furthermore, to make the link between the Dustiness data and the prediction of occupational exposure via the source terms and via the elements of basically energy and kinetic factors, we would appreciate that if people are interested to join us to expand the data that we have so far that we are on continuous drop and the small rotating drum, to expand that to the other devices, the other equipment. In terms of HARN now for the TG, basically HARN high aspect ratio, we agree that on the most important measurements. We agree also on the type of aerosol sampling and instrumentation techniques via SEM and TEM that would be used, and that are potentially useful for rich framework. Here you have a slide on the right here that shows how from the microscopy, electronic microscopy, you can measure the length, the diameter of fibers, the aspect ratio for the WHO type of fibers. Here on that particular type of morphological measurement, we are going to launch next year an official call for participation to HARN type of measurement, beginning of 2021. and to be completed in the end of September 21. So please contact Bauer, Anna Paul for this, but we'll send an official call for this also. Next, please. So altogether, we hope that the TG will be able to deliver that in April 2022, the GD in April 2023, and we thank all the people involved, I mean 40 people, and we'll continue to discuss these things with you, to discuss these issues with you in very near future. So thank you all on your fruitful discussions and interactions that we had for the last few days. Thanks so much.